So I've posted a file containing all the data I'm going to show here. And I'm just going to go through what dbeaver's reaction is to some of the stuff in the lecture on database modifications. So the first thing to note, and if you try this out, of course, do this yourself as well, I am over here on my bBird database, my individual database. And so you should be running these commands on your individual database as well. You will not be able to run them if you try running them on one of our big databases. So the first thing is, because obviously you don't have any of the schema or data that I do, the file I post will contain everything to create the schema to work with. And so here I'm dropping my tables if they exist. There I'm creating a products table, then orders, then order contents, and then adding all of my usual data. So in dbeaver, if you have a long SQL script and you want to run everything in it, it's pretty annoying to have to press Control-Enter on every single statement. So what you can do is, if you go under the SQL editor menu, I'm realizing now my screen capture isn't catching that. There is an option in the menu called Execute SQL Script, and the hotkey for it is Alt-X. So I'm just going to press that, take my word for it. And we can see it just ran through everything. It noted that it ran 25 things, and it updated 19 rows in total, and it took 0.5 seconds. That's not too bad. And so it's now added all these things, and just to verify that, I could go over here and I could run something like select star from products. And there it is. One thing that's beneficial about the way this script has been written, as I mentioned in the lecture itself, at the beginning of the script, I have drop statements for everything that I'm going to create, which you'd think is a bit weird, because why would I need to drop them if I'm just about to, why would I assume they already exist? Why would I create them more than once? And the answer is because then I can run this script as many times as I want. Every time it runs, it clears the slate and then creates everything again. And so that's very useful. And on assignment 6, when the time comes, you'll be expected to do the same thing, to add those at the beginning so we can rerun your schema creation as many times as we need to. Okay, so we have this. Let's try doing a few things here. So I'm going to skip back and forth between queries. So select star from products. I already have, well, I'll write it again. My brain wants to write this again. There I have all the usual products. Let's try performing some delete or update statements. Delete from products where price per kilogram is less than 6. So I run this. In this case, it says, I'm sorry, I can't delete some products. Now, dbeaver is giving me an error here because the database server has rejected my attempt to delete. And maybe it's hopefully visible on the video. It actually gives an explanation of what went wrong. Product ID 2 is still referenced from table order contents. Let's go back over. And we'll query the table. Product ID 2 is a pair. It turns out that there's something in my order contents table where product ID 2 has been ordered. And therefore, there's a row in another table that refers to this row here, and so the deletion fails. Now, on the other hand, if I do product ID equals 1, if I delete every row where that holds, I run that, it apparently works, and then I can look at the table again. Product ID 1 isn't there. And that's because this deletion succeeded because there's no order that contains product ID 1. But to clarify, if I try to delete the rows with product ID 2, then I get an error again. The deletion simply fails. And just to clarify another thing here, I tried earlier to delete every row with price less than 6, and it failed on product ID 2. But there were several other products with price less than 6, including apple, including pineapple, that it could have deleted, but it didn't. If a delete statement fails for any reason, no modifications are made. And we'll see in I think 2 lectures from now, I guess, that's an example of what we call an atomic operation. Either the deletion succeeds, which means it completely succeeds, or it completely fails. There is no middle ground. Okay, so I want to get my data back here. So I'm going to go over here, rerun my entire creation script, and then verify that everything's back where it started. Okay, that looks good. So we've tried the delete statement. Let's try the update statement. Update products. I'm going to set price per kilogram is equal to 100, where price per kilogram is less than 6. And we see the update apparently affected 4 rows, and it did succeed. And if I take a look at what's in the table now, we'll notice everything whose price was less than 6 now has price 100. So I'm allowed to make the modification to those rows because the rows still exist. The other tables that refer to product ID 2 or 3 can still refer to those products. Let's try a different update. Update products and set product ID equals 100, where product ID equals, let's try 2 and see what it does. And in this case, the query works perfectly. And I want to foreshadow something that we're going to talk about in the next lecture here, but let's take a look at order contents. The order contents table used to contain 2 rows that referred to product ID 2. When I updated the ID of product ID 2 to be equal to 100, it succeeded, and the update propagated to the other table. That's significant. So the foreign key constraint provided me 2 types of protection. 1, it would not let me delete the product because something else needed it. 2, if I wanted to modify the product ID, I was allowed to, and the modification propagated through any other tables. So we'll actually see in the next lecture what's really happening there. But the key for now is that I was able to perform these update operations. Now, because I don't want that to stay there, because I'm going to need this for the next example, I'm going to go back and rerun my schema creation. Okay, so my table's been reset. Let's head back. Let's head back over here. So it's weird that the screen capture doesn't catch like boxes that pop up, because every time you notice me going oops or something, there's actually a box popping up that is complaining about something and you don't get to see it. Okay, so we'll just make sure that my products table is back to normal. Yep, looks good. Let's take a look at some of those function creation statements. Okay, so this is the first function we saw in the lecture. I'll do Control Enter on this line. And it's actually going to complain about this. So maybe what I'll do, because I ran this before I started the video. So another reason to have the drop function if exists notation. So I'm going to drop this function first. Okay, there we go. It deleted something. I didn't update any rows of any tables, but it did delete a function. I'm now going to rerun this. Okay, so the query, it lists the whole thing. It ran the query and then created the function in the database. And we notice that if I try and run it again, it'll complain again. It'll say, sorry, I've already done that. I won't do it again. So let's try using this. So I'm going to do select name, product ID from products, just to make sure that works great. And then I'm going to select is delicious of name, because the function takes a product's name as its argument. Let's see whether we can hold out hope that we'll be able to get everything on the same screen here. So we'll try that, and we'll notice that, when it sees the name pear, it returns maybe. That should be a yes. Raspberry, definitely a yes. Pineapple, definitely a no. And the other ones, I think, are quite reasonably maybes. So the function is being called each time, and it's returning a value. Let's see what happens if I give it the wrong type. So if I give it the wrong type, it says, I don't know what you're talking about. Postgres goes looking for a function called isDelicious that takes an int, and it can't find one. So just like in a language like C++ or Java, the types of the arguments are considered part of the function's identity. It then actually suggests, I don't know if I should try this, it says, hey, if you really want to call this function, you have to add a cast or something. Like it's suggesting, hey, maybe you did mean to pass in a number, but you need to convert it to a string first. Yeah, okay, you could do that, but it is trying to tell you that that's not a good idea, that the function you've written apparently doesn't work with the argument types that you've provided. So we'll set it back to this. Okay, so here's our getOrderPrice function. So I'm going to run this drop statement here to get rid of it if it already is in there. And then I'm going to run this to add it to the database. There it is. Okay, and then let's run this query, and this is actually from the lecture here, that goes into the order table and then calls the function on every order in the orders table. So we can see it is calling the function, and because of the nested SQL, we never actually have to worry about how do you compute an order's price again. We just have the function do it for us. So if I really suggest, like, the next thing you should do is learn how to connect to your personal database. Go to the Databases tab on Connex, read about that. Make sure you can connect and send me an email if you can't, and then download this script that I've posted and run it. Just run the queries. That's all I ask of you. This notation, as I said in the lecture, this is really hideous. But you'll discover that once you've seen it a few times, writing one of these functions isn't so bad, because usually you just copy and paste this part, you copy and paste this part, and you stick some pretty basic stuff, an if statement, a couple of assignments, or a return, and so you can work around the syntax. But it gets much easier once you've tried it. So go try it, and then watch the next lecture, I guess.